How many planets are in our solar system? The typical answer these days is 8, but that might not be the best possible answer. And the story goes much deeper than just one particularly lovable ball of ice out past Neptune. In fact, there could be well over 30 planetary bodies scattered throughout the solar system. Let's explore. The International Astronomical Union, or IAU, has a 3-part definition of what makes something a planet. First, it has to orbit the Sun. Second, it has to be large enough to make itself round by its own gravity. And third, it has to have cleared the neighborhood around its orbit. Essentially, the IAU planets are the largest objects orbiting the Sun that define regions of our solar system. You could talk about a near-Earth asteroid versus a Mars-crossing asteroid, for instance. 8 planets make this cutoff, which you're probably familiar with: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The IAU planets are good at defining zones of the solar system, but it's pretty easy to find holes in the IAU's 2006 definition. If you were at all aware of planets in 2006, you'll already know about the Pluto controversy. Pluto is a gravitationally rounded icy world which has not cleared its orbit, being orbitally bossed around by Neptune, even though it was considered a planet for decades. The IAU declared Pluto to be a dwarf planet since it meets the first 2 criteria and not the third, along with a handful of other objects that meet the same standard, including then newly discovered Eris, which is more massive than Pluto but slightly smaller in volume. There's also the fact that the neighborhood criterion makes Mars less of a planet than Mercury. Not to throw shade at Mercury, though it might actually appreciate some shade. In any case, there are reasonable arguments for and against the IAU definition, but for the purposes of this video, none of this actually matters. You see, if you study planetary geology, that is, geology without the geo part, then it makes more sense to classify planets not as objects that define a region of the solar system, but rather as just anything that's the right size for geology-ish things to happen to it. This includes having planetary layers like a core, mantle, and a crust, and that second criteria of being rounded by its own gravity. Alan Stern, the principal investigator of the New Horizons mission to Pluto, and Harold Levison created their own definition of planetary bodies in 2002, reflecting these parameters. First, a planetary body has to be large enough that its shape is primarily determined by gravity, and second, it has to not be large enough to ever undergo nuclear fusion and become a star or a brown dwarf. Planetary bodies that orbit a star or stars are called planets, ones that orbit a larger planetary body are planetary-scale satellites, and ones that do not orbit either are unbound planets. So, what are all of the solar system's planetary bodies? All of these guys. We have the 8 IAU planets, nice to see you again, and at least 3 former planets: Pluto, Ceres, queen of the asteroid belt, and the Moon. Ceres, as the first asteroid discovered, was grouped as a planet for quite a while after its discovery in 1801, and asteroids generally were considered planets perhaps as late as the 1950s, at least according to Alan Stern. The Moon, for its part, was considered a planet in the ancient Mediterranean, with the word planet coming from the ancient Greek word planetes, meaning wanderer, and encompassing all the celestial objects that wandered through the sky, including the Moon and the Sun. These 3 former planets each represent one of the 3 categories of planetary bodies other than the IAU planets: Ceres leading the large asteroids, Pluto leading the outer solar system ice balls, and the Moon representing the moons. Let's start with the asteroids. Other than obviously round Ceres, the other big asteroids, including Vesta, Pallas, and Hygiea, are borderline planetary bodies, being not obviously round themselves, but bigger than some other gravitationally rounded objects in the solar system. We know a lot about Vesta in particular from NASA's Dawn space probe, which visited Vesta in 2011 and Ceres in 2015, and from meteorites that originated on Vesta and have fallen to Earth. Vesta probably has a separate core, mantle, and crust, and was probably round in the past when it was warmer and more flexible, before being knocked out of shape by impacts with smaller asteroids. One such impact left the giant Rhea Silvia crater, named for the mother of Romulus and Remus, the legendary founders of Rome. The central peak of Rhea Silvia, formed by uplift after the impact, rises 14 miles or 22 kilometers high, rivaling Mars's Olympus Mons. Next, let's turn to Pluto and the other trans-Neptunian objects, including Eris, Makemake, and Haumea, the IAU-recognized dwarf planets along with Ceres, and the probable dwarf planets like Quaoar, Sedna, Gonggong, Orcus, and Salakia. Pluto is the only one of these that's been studied up close, by the previously mentioned New Horizons probe led by Alan Stern, so we don't know much about the others other than their general size, shape, and color. Even these can tell us, for instance, that Makemake is very reflective, and Haumea has spun itself into being an ellipsoid. We also learned Haumea has a ring by watching it pass in front of a star. Many of these icy dwarf planets lie in the Kuiper belt, a band of objects just outside the orbit of Neptune, but some are even further out. We don't know exactly how big an icy object needs to be become round, but we do know that ice is more flexible than rock. This means there are dozens more known icy objects that are also possibly planetary bodies, including a couple of the centaurs, which orbit closer in than Neptune, but farther out than Jupiter. There are also probably many more undiscovered icy planetary bodies hidden deep in the outer solar system. Sedna takes more than 11,000 years to orbit the Sun on an extremely elongated path. The fact that we got lucky and caught Sedna within just a century of its closest approach to the Sun suggests that statistically, there are at least several dozen Sedna-sized objects out there on the distant parts of their own elliptical orbits, and maybe hundreds or thousands even farther into the outermost regions of the solar system. Maybe one of them might beat out Pluto, Mercury, or even Earth. In 2014, scientific speculation grew about a possible distant Planet 9, several times larger than Earth, that could have kicked objects like Sedna into their strange orbits. We haven't found Planet 9, but given how far away it's predicted to be, it could still be hiding somewhere. The last category of planetary bodies in our solar system are the planetary scale satellites, or big moons. Just like asteroids, moons were also once considered planets by scientists, at least according to a 2022 paper led by Philip Metzger, also featuring, you guessed it, Alan Stern. I guess you really end up with a bone to pick with the IAU when they demote the target of your space probe. In any case, not all moons are big enough to be planetary bodies. Mars's moons, Phobos and Deimos, for instance, are so small that not only are they not spherical, they barely hold themselves together. Earth's moon, confusingly called the Moon, is of course the most familiar of the planetary scale satellites, and is one of 7 moons larger than Pluto and Eris. Let's examine the other 6. Neptune's moon Triton might be a captured dwarf planet. Saturn's similarly named moon Titan is the solar system's only moon with a thick atmosphere, and the most distant world that we've ever landed a probe on. It even has lakes made of hydrocarbons near its poles. Jupiter's moons Io, Europa, Ganymede, and Callisto were seen by Galileo with his telescope in 1610. Io is teeming with volcanoes, which are powered by the tidal flexing from the gravity of Jupiter and Io's neighboring moons. Europa is sheathed in a layer of ice, likely covering up a vast underground ocean. Ganymede, the solar system's largest moon, has its own magnetic field, and maybe its own underground ocean too. Both Ganymede and Titan are larger than Mercury, though Mercury has more mass. Callisto is the farthest out of Jupiter's 4 large moons, and has the most craters. In addition to these 7 giant moons, there are 12 more moons in the solar system that are known to be round or nearly round. 6 of them orbit Saturn: Mimas, the solar system's smallest round moon, and which looks like the Death Star; Enceladus, which has giant ice geysers at its south pole; Tethys, the only major moon that's less dense than water; Dione, which like Tethys has its own co-orbiting Trojan moons; Rhea, which scientists briefly thought might have rings, but now they think it maybe just used to have rings; and Iapetus, which has a giant dark splotch and a huge mountain range on its equator. Another 5 round moons orbit Uranus: Miranda, which has the solar system's tallest cliff, and Ariel, Umbriel, Titania, and Oberon, which all look pretty similar, and which probably have cool features that I could share with you if they were visited by more than one brief flyby from NASA's Voyager 2 probe. Rounding out the list is Charon, Pluto's largest moon, which is so large that it doesn't technically orbit Pluto at all, but rather both Pluto and Charon orbit a point between the two of them. Some other dwarf planet moons like Eris's moon Dysnomia might be round as well, but we're not sure. So with 8 IAU planets, 5 recognized dwarf planets, 5 likely dwarf planets, 3 roundish giant asteroids, and 19 round moons, our solar system hosts at least 32 to 40 planetary bodies, and maybe a lot more. Each one is its own case study on how worlds form and evolve, and no two will tell exactly the same story. Knowing that there are so many worlds out there to explore is exciting for all of humanity, including, of course, Alan Stern. Be sure to leave your feedback in the comments and subscribe if you want to see more like this. And as always, thanks for watching.